Hello friends, today we are going to deal with the theorem of geometry, that is to from chapter number first. It is nothing but similarity, and then name of the theorem or heading of the theorem is BPT, that is basic proportionality theorem. Basic proportionality theorem, that is BPT. So this is an very important type of theorem for exam point of view. Like this is being asked so many times for the state board questions or state board exams. I have seen many of the times in the question papers that they are asking this theorem BPT for 3 or sometimes 4 marks. So for that, here they have given us a statement, and along with the statement there is diagram. So what the statement is saying, if a line is parallel to a side of a triangle, intersects the remaining sides in two distinct points, then it divides those sides in same proportion. I have made little bit changes in the sentence that here those two sides I have taken over here, and there is little difference in the wording of the statement. So what statement says, if a line is parallel to any of the side of triangle and that line divides the other two sides of the triangle into distinct points, then this line divides those two sides of triangle in same proportion. What does it mean? It means if there is any triangle, suppose, and there is any line which intersects the one of the side of the triangle. Suppose I am having uh, a parallel line to this side of the triangle, like this. Suppose this line is parallel to this side of the triangle, then, and if this is intersecting these two sides of the triangle at two different points, two distinct points, then what is theorem saying is this line will divide these two sides of the triangle in same proportion. And so if you take the ratio of this side with their sections, and again if you take the ratio of this side of the triangle, then these ratio will come equal. So this is what the statement is saying about the diagram. So here we have taken triangle ABC in which line L is parallel to the side of triangle BC. Okay. So and the line L is intersecting side AB and AC at two different point P and Q respectively. So we'll have that in the given section, whatever the in the there is in the diagram. So we'll write it over here. In triangle ABC, line L is parallel to one of the side of the triangle, and that is BC, side BC, and line L is intersecting. Line L is intersecting other two sides, other two sides in two distinct points, intersecting, that is AB in point P and AC in point Q. Okay, so whatever there is in the diagram I have written in the given section. Now what we have to prove is that if we take ratio of this side and this side, both ratio will come same. That is what we have to prove. So it is like AP by PB comes equal to AQ by QC. This is what we have to prove, because this is being asked in the statement, that if a line is parallel to one of the side of the triangle and is intersecting on the two sides into distinct points, then it divides those two sides of the triangle in the same proportion. So for this to be proved, we have to make some construction, and for that I am drawing here BQ and again PC. So these 2 points we are joining. So join, I'm writing in the construction part of the theorem of BPT that join PC and BQ. Okay, got that? Now this type of diagram I'm having over here in my sketch. So here it is like, suppose this is point A, this is point B, this is point C. You can see like this, C. So this is the triangle in which line L is parallel to BC and line L is intersecting side AB in point P and side AC at point Q. Now again I have drawn here by joining BQ and PC so that the diagram is like this. Now before we'll go further, I think you have gone through the earlier part of this chapter. It was the ratio of areas of two triangles. What was that? It was like ratio of area of first triangle to the area of second triangle is what? Product of base height of first triangle upon product of base height of second triangle, isn't it? I think this you have gone through it, so you remember this for the proof of this theorem. So if this was one of the case, then there was another case that if the triangle has same base, then the base will get cancelled and the ratio of areas of two triangle will be like the ratio of their heights, respective heights only. If that, then another case was there, if the triangles are having heights as same, then heights will get cancelled, so that the ratio of areas of two triangle will be only the ratio of their bases. Similarly, if the triangles have both base and heights as same, then these both will get cancelled and the ratio will come to be equal to 1, and then you can transfer this to other side, then you will have that area of triangle 1 will be equal to area of triangle 2. These four cases of the ratio of areas of triangle you have seen already before solving this theorem, and you have to remember those ratios to solve this theorem also, because they are needed over here, like you will see in the further. Okay, now here there are, initially there are two triangles, like here it was APQ smaller and then ABC which was bigger triangle. But when we drawn this PC and PQ, we got more triangles in this diagram. Now here we'll have to take, now here we'll have to take a ratio of two triangles, like here what we did. So in here we'll take pairing of triangles, like suppose we'll take APQ and another triangle, suppose PQB. What I'm saying is we'll take triangle APQ and triangle PQB. Which are those? I have little diagram of this, and it is like this. Okay, if you put this over here, it is like this. So this upper triangle is APQ and this lower triangle is PQB. So I'm taking these two triangles initially. Okay, so I have written here in triangle APQ and triangle PQB. So if you just rotate this triangle like this, and you will have that A point over here, B will remain at this place only, and then this Q will be over here. If you rotate it will in this direction, like it is in anti-clockwise direction, then you will have this APQ and PQB like this. So if you remember the formula for areas of two triangles, in this case, if you take area of triangle APQ, so it has its base like AP and it doesn't have proper perpendicular height. So for that you have to draw here the perpendicular. Okay, so just remember for a while that if you take area of triangle APQ, it will be like half base into height. So here base is AP, and then here it will be height. Well, we don't have here height, but we have to take that. Okay, now, if you take this one triangle, that is PQB, so it will have like here P, here B, and then here it is Q. So PQB in this triangle also there is base, it is PB, and height. For that you have to draw perpendicular from here onto this. So these are the two triangles which has same height. Remember, so these are two triangles with same height, and so I can write the ratio of these two triangles, the ratio of areas of these two triangles will be like a ratio of their only bases, because the areas are proportionate to the bases. Since they have same heights, so same heights will get cancelled. So I will have to write here that area of triangle APQ upon area of triangle PQB. So it will be like a ratio of their bases only. So base of triangle APQ is AP upon base of triangle PQB is nothing but PB. So I can give this as equation number 1. And how this come to this comes to this is because the areas are proportionate to basis. And why they are so? Because they are having same heights. So heights are gone cancelled, isn't it? Now we'll take another pair of triangles. Suppose again we'll take APQ, and then we'll have PQC, this one. Okay, so here again I have its um, diagram, and it is like this. So it is APQ, okay, and then PQC, this. So if you rotate this diagram again like in clockwise direction, you'll have it like this. So C will remain here, and this P will be like here, and A will go to this side, isn't it? If you rotate this with this. So now here also, if you see that the APQ for this triangle, the base is AQ, isn't it? APQ. So AQ will be the base, and it doesn't have perpendicular height. So for that you have to draw height perpendicular to this from point P. Now in case of this triangle also, it is what is that triangle is PQC. So for this also there is QC is the base, and it doesn't have perpendicular height. So for that you have to draw height from here. So these again in this case also, for these two triangles there is perpendicular height which is common for both the triangles. So if you take the ratio of these two triangles, you will have the areas of those two triangles will be equal to their ratio of their bases, isn't it? So I will write it here that in triangle APQ and that is PQC, in triangle PQC, if you take area of triangle APQ divided by area of triangle PQC, what you will have is the areas will be proportionate to their bases since they have same height. So the base of triangle APQ is like AQ, and PQC has base QC. So I will give this as equation number 2. And what is the reason? Here is also areas are proportionate to bases. Why it is so? Because they have same height. So heights has gone cancelled out. Okay. Now we got two equations. See what we did is we had taken this triangle and this triangle initially, isn't it? I mean we took APQ two times. APQ along with PQB, and then again APQ with along with PQB. PQB and PQC are the two triangles we have taken along with APQ as common in both the cases, isn't it? Now, what we'll do further is we'll take only these two triangles because we are taking pairs of triangles. Initially, we took this and this triangle, that is APQ and PQB. Then for second time, we have taken triangle APQ and then PQC. Now what we'll do is we'll take PQB and PQC. Okay. So here I'll write that. Now in triangle PQB and triangle PQC. See, I'll show you the diagram of these two triangles. Like this is line L, and there are points P and Q like this. And there is point C, there is point B, and the triangles are like this. So this is PQB, and this one is PQC. Okay, so you know that line L is parallel to BC, which is given already. So this is nothing but the trapezium. Like PQCB is nothing but a trapezium, and so for these two triangles, the heights will be same because heights are nothing but the distance between these two parallel lines. So if you just move this side BC to the upper side, so the diagram will be like this. If you take B to this side, suppose I will show you that diagram so that it will be easier for you to remember. So this is line L. So there is point P and there is point Q. Okay, and this is BC. Okay, now you have joined this and also this. So you got two triangles, PQB and PQC. Now if you just take these BC points and hold them and put them over here, so that you will have a diagram like this, a diagram like this. So this will be B point and this will be C, and this will be the triangle PQB. And again, if you join this, you will have PQC. Okay, so here you will come to know that the in triangle PQB, in triangle PQB, the base is PQ and height will be perpendicular from this onto this line, isn't it? Now if you go to the triangle PQC again, PQC, the base is PQ again, and height, for that you have to draw perpendicular from this to the PQ. So if you remember what trapezium is any quadrilateral which has two parallel lines. So this is nothing but the trapezium. It has two parallel lines, two parallel sides actually. So the height between the height of these two triangles is the perpendicular distance between these two parallel sides, isn't it? So I can say that these heights are same. But if you see that in both the triangle PQB and PQC, bases are also common. There are that is same. So these are the two triangles with same base and same height. So I will have area of triangle PQB upon area of triangle PQC will become 1. Why it is so? Because these are the triangles having both same heights and bases, isn't it? These are the triangles having same both height and bases. So they got cancelled, isn't it? So I can convert this like this. Area of triangle PQB is equal to area of triangle PQC. If you just move this denominator to the other side it will be like this, isn't it? Now, if you divide this equation number 4, if you divide this equation number 4 by the triangle that you left behind, it was APQ, isn't it? So if you divide this equation by area of that triangle APQ on both sides, you will have like this: area of triangle PQB divided by area of triangle APQ. So on right hand side it will be like area of triangle PQC divided by area of triangle APQ. What I did is I just divided this equation number 4 by area of upper triangle, that is APQ, on both sides. So I got this. Now if you invert this, like if you change numerator to denominator and denominator to numerator, you will have this to the upper side, that is area of triangle APQ divided by area of triangle PQB, and here similarly you can have area of triangle APQ upon area of triangle PQC. So finally we are getting answer, because we do have these already solved in equation number 1 and 2. Just see here, area of triangle APQ upon PQB is what? AP by PB, and on that side area of triangle APQ upon PQC is what? AQ by QC, and this was being asked to prove. So we got that AP by PB equals to AQ by QC, isn't it? So how to remember this? For that to be proved is we have to first take this triangle, and then along with this triangle the pair of triangles should be PQB, and just rotate this to this side, then you will have those two triangles with same heights. So their ratio of areas will come to be equal to the ratio of their bases only. Again you have to take next pair, that is a upper triangle APQ and this PQC, and for that you have to again rotate this to other side, right, in the clockwise direction. Then you will have the triangles with same base heights, and therefore the ratio of those two triangles will be the ratio of their bases. Then next time, for the third step, you have to take these two triangles, that is PQB and PQC. These are the two triangles which are formed between the two parallel lines, so they have same base and same heights, so their ratio are equal. Then you have to divide this equation by the leftover triangle, that is upper triangle, and its area, so that you will have the equation like this. And these are already solved from equation 1 and 2. We have written this. Understood? Hmm? If you like this video, please do like my video and do subscribe my channel. Okay.